This is a late 1960s Zenith combo unit. Chassis is 14Z8C50. So it's a 14 tube chassis, color set, Space Command 600. This is a full remote set, that's why it doesn't have any knobs, the traditional channel selector knobs. It has the solid state AM FM tuner. I've done videos on that before, aligning it and such. I believe the vertical output transformer is bad in this. And why do I believe that? Because it smokes, and that's usually an indication that the insulation has failed. So we're going to turn it on and look at the symptoms and kind of look at how to test that. So like I said, it's a full remote set here, so that's power. And in order to change the vertical output, you have to yank the chassis. Wait until it comes up. In fact, this is all we're getting right now, and that does not seem right. Let's see what we got here. Ooh. Ooh. Arc it. Wow, that's not good. What's going on here? We got fire going in the flyback here. Wow. Carbon tracking. Imagine that. Crap. The focus wire is all carbon tracked. Let's get that out of the way. Look at the way that transistor is mashed over. And someone bypassed the fuse right there. Okay, let's see what's happening up front. Okay, this is what I'm getting. No vertical deflection. Now on Zenith, the vertical output transformer drives the convergence assembly. Yeah, the focus is going klooky doobler there, isn't it? So what I'm going to do is I'm going to unplug the convergence assembly. Man, this thing is... Boy, this thing is emitting all kinds of different odors. Let me unplug it here. Corona. Okay, the convergence assembly on this is up front. So I'm going to reach in here and unplug it. There's the plug. So the convergence, wow, that's a burning smell. The vertical output transformer on this can either short from the, yeah, there's smoke coming up. It can either short from primary to secondary or to the convergence winding. So let's see what we get with the convergence unplugged. And look at that. Sort of exactly what we would expect, minus the focus issue. Yeah, kind of exactly what we would expect with the Blambulance. Yeah, the focus is trashed now, so I have a feeling something got fried when it was arcing. This set's never worked. So we need a vertical output transformer. We need to fix the focus. And yeah, that's a brand new CRT. So I'm going to try and yank the chassis. Here's the vertical output transformer. I got the chassis out, and it's burning hot, and it smells like burning enamel. So that pretty much confirms the diagnosis. I'll be curious to see if we can ohm it out. Have to go through. Ooh, look at these Elminco capacitors. Those should go. But Zenith hand-wired, handcrafted beauty. Too bad it's only a 14 tube. This is what we got going on. What I really wanted this video to be about was getting the transformer rewound, sending it in, because these are pretty much becoming unobtainable, sending it in and getting it rewound at one of the 2 or 3 magnetics transformer winding companies that are still in business in this country. And what I was going to do is send in the smoked transformer and a known good replacement. And I have 3 transformers here. I borrowed 2 of them from a friend who refuses to sell them. I have a new old stock Zenith replacement. This is the exact same part number. I have a pull out of a Zenith, which is the same Zenith part number, but it is a pull. We don't know if it's good or not. And then I have the Thordarson replacement. The plan was to test these 3 and compare them. And the way I'm comparing them is I've got a, what is that, a 5 or 7 watt bulb in the dim bulb tester, and I'm feeding that into the blue and red, which are the primary. Blue goes to the plate, red goes to B+. And with the bulb in series, I have 112.5 volts on the primary. And what I'm going to do is go through and I'm going to measure all of the secondaries, and I'm going to write them all down, and that way we can calculate the ratio of the different windings. So you have this right here supplies the yoke, the blue, white, red, white, and black, and then this down here supplies the convergence. And as you saw in this set, what we have is we have a short from the primary on the left to the convergence windings. So the idea was, again, to send in the smoke transformer, a known good transformer. Hey, rewind this thing and document it, and I'll order a couple, and then maybe you'll be able to sell some other ones to some other Zenith owners. And this is a very common transformer. This is used in almost every Zenith rectangular tube set. So this would be something, but I call them, they're just not interested. And they say, yeah, 4 to 6 months we might get to it. We're short-staffed right now. We're having trouble getting supplies. 4 to 6 months, and somewhere between $400 and $600 to fix that for you. And it's just like the attitude is, we don't really want to waste our time with something like that. You know, it's amazing that in this country you just can't get anything done anymore. It's like that everywhere in small business. I deal with that type of attitude and service in so many different aspects of life now. It's just, and it's getting worse. All right, here are my findings, and keep in mind I'm using a current limiting light bulb on the line. That way, yeah, I'm not exposed to, if something shorts out, damaging anything. So the light bulb is why the input voltages vary as the transformers vary. So the black is a 26S60. These are my voltages: 112, 9.25, 9.25, 8.3, 1, 3.96. Then the Zenith, the new Zenith, which pulled through the light bulb, had more loss in it, or more draw, so it dropped the input voltage to 97.8. And I still ended up with more voltage here, more voltage here. So the red, all the red, and then the Zenith used. And then, of course, I took one of these leads and touched it over to all of these, and then the other one to analyze if there was a short between, and there is none. So the used Zenith transformer that I have, the pull is good. And I had started a video on this probably close to a year ago, trying to address the vertical output transformer failure in Zenith televisions. That's the intro part of this that you've seen. And I was attempting to find somebody to rewind the vertical output transformer in this set. Well, it never happened. We talked to one guy at a transformer winding company. He said, send me what data you got, I'll look it over and get back to you. Never got back to us. So I kind of just put this set in the back room and fixed the CTC 25. So this has just been sitting here up on its end. Well, I recently received a message from a viewer in Poland who has a YouTube channel, and his kind of hobby is winding transformers. And he was very interested in taking this transformer apart and rewinding it. And looking at his YouTube channel, he seems to know what's up. He's really passionate about it. Looks like he bought a CNC transformer winding machine, and he's got all the math down and the types of insulation. So he says, send me that transformer. So I'm going to pull the transformer out. We'll pull the chassis out. I'm going to send it to Poland, and we'll hopefully do sort of a co-video collaboration. That's the word I'm looking for, a collab. We'll do a collab video, getting this set back up and running. So I got to get the chassis back out and pull the vertical output transformer, and we'll ship it off to Poland. Also going to send one of these flyback transformers, which is out of a Packard Bell, but is the same as RCA CTC 16, 15, 17, all of those. And what usually fails is just the secondary coil, this part right here. The primary down here is usually okay. It's just the secondary. Gonna remove this thing and get it sent off to Poland.
Hello Shango channel viewers, greetings from Poland. This is Marko from Markos Channel, and today I'm going to show you how I unwind the transformer and flyback. So I was very excited when Shango sent me this transformer. This is a Zenith color output transformer, as you probably saw in his video. So I'm going to dissect it using this Sheffield knife and a little bit of help from the hammer and some other tools that you will see in this video. This transformer is extremely similar in its construction to the single-ended output transformers for audio, so the all sorts of different gapped transformers which are used throughout audio, hi-fi and similar guitar amplifier devices. So the E laminations and I laminations are separate, as you can see. So they come separately, and that makes it a lot easier to disassemble. Otherwise it would be really difficult when they are interleaved. So I managed to expose the bobbin, and now I'm panicking and I'm pretty stressed because these leads are very fragile, and you can see where the burnt part of the transformer is, which probably fried either in that spot or later on once the whole winding started heating up. So one thing which I don't understand is why they originally didn't use the sleeves of any sort on these connections, which have high voltage spikes on them, but I guess the technology at the time was done in such a way. So here I'm slowly trying to find the place for original place for each of the wire leads, which is also pretty difficult because the whole thing is pretty crusty, and you can see how it was baked over the years. Yeah, I tried my best to get to the thicker wire, because the thin wire was scorched and very difficult to unwind, which resulted in me not really unwinding it, but just cutting out the thin gauge wire turns. So after I checked which lead goes where and carefully marked all the starting and ending wire leads, which is important to get all the phases right, I simply removed the convergence windings and the primary winding, which were done with the really thin gauge wire, and I focused on the secondary and another convergence winding, which are wound in a bifiller fashion with a thicker gauge wire, which is really easy to unwind and to count the number of turns, which I did successfully. And we just used the sine wave method to determine by feeding a signal to a primary or secondary. We determined the rest of the turns by using the formulas for the turns ratio. I started an unwinding, and you can see that that can be a really tedious process if you are unwinding a lot of turns, especially if it's a thin wire. And you can see even the thick wire is really scorched and baked. So I just unwound the whole winding and counting on this. This winding was this is the one of the convergence windings, if I'm not mistaken. And later I managed to unwind the secondary windings as well too. So I carefully marked the order in which the transformer was wound to manage to replicate it as close as I can once I rewind it on the modern bobbin. This convergence winding had 90 turns. Yeah, so you can see this one, since it's only 90 turns, it was not that difficult, but I just wanted to leave it here in the video so you can see how tedious it might be if you have thousands of turns, which you need to unwind and not to go crazy while unwinding it. So once I had all the windings unwound and everything calculated and ready to go, I took the plastic bobbin, so the modern plastic bobbin, and started winding on my CNC winder, as you can see here. Of course, it was not, I didn't do it in one attempt, so you can see a mix of several different attempts. I just wanted to see what layout would work the best. Organizing these leads, I'm not really sure how critical it is in the sense of mounting it in the TV set later on, but I tried to separate the primary windings from all the rest of the windings as best as I could, so that in order to avoid any shorts or spikes in the future. Hopefully that worked out. We will see once the transformer is tested. So the secondary windings are wound in a bifilar fashion, so it means two wires wound at the same time to get symmetrical or even balanced windings with the same DC resistance. I'm not sure how critical it is in this application, but I just did it the same as the original had, with the slight difference that I didn't use a paper layer between each layer, paper insulation between each layer, because the modern wire can withstand quite a lot of voltage. So you can see some of the attempts where I wind the secondary. So getting it all aligned and having all the perfect spacings and everything took a little bit of trial and error, but finally I got there. So I wound the secondary, and of course it's critical to use good insulation between primary and secondary and all the different windings to separate them from each other, and for that I used Kapton tape, which is a perfect insulator. And yeah, once everything was ready, I had to separate all the leads and rather solder all the leads to the wires, and finally insert the laminations, and it was time to pot it in enamel, so transformer lacquer or enamel, or I just let it there for some time. Then it was time to unwind the flyback from the Packard Bell color television set, which as Shango said, it's the same as the RCA CDC 16, if I'm not mistaken, and all the similar sets that clone RCA chassis and circuits. So this flyback had shorted secondary, which seems to be 20, 21, 22, 23. And you can see that this system provides a nice result. The CNC winder does its job nicely, and yeah, so it's ready to be mounted back, and hopefully it all works. So
Oh, well, we got a box here from Poland, and it cost about $80 and took 3 to 4 weeks to get to Poland, and it cost $40 and took 2 to 3 days to get back to the United States from Poland. So something is grossly wrong, and we can see our package has been inspected by U.S. Customs and Border Protection. I don't know what border they're really protecting, and if they're spending their time inspecting a box with some transformers in it, their efforts are grossly misdirected right now. So Marco has his own YouTube channel where he winds a lot of, looks like, transformers for audio, tube audio output transformers. I wonder how he had this packaged. It looked like they were looking for fentanyl, maybe. I hope they didn't unwind the transformer looking for fentanyl, but these days you never know. So here's the flyback with the secondary rewound with modern synthetic he did not solder the wires back on for the primary. He told me that this is a Packard Bell flyback, and you can see the stack of wire there, the winding. That's pretty interesting. Now theoretically, this should never fail again like this. This insulating capability of this tape far exceeds paper, especially when paper is damp. But yes, so this is an experimental deal. So this flyback is the same as would be on an RCA 16, 17, 25, 35, 15. It's basically the same build, and really only the secondary ever goes bad on these. The primary is so few turns that, yeah. So there's our flyback. And let's see here. These are 2 vertical outputs. The one I sent that was smoked, and one more that he built. Let me open this. So here are the 2 new Zenith vertical output transformers, which are the same as this right here, which this transformer substitutes, well, it's the same as this to the 26S60, which this works in most all of the Zenith rectangular color sets. The 20X series, a lot of the 14 series. So this, yes. Wow, what a difference. Wow, and they smell. They have a very unique smell. Paint. Let's match one up to this one. These are homemade vertical output transformers. Wish I could have it should fit. Should physically fit, because in the chassis this goes under one lip and then there's one screw that holds it down. So wow, awesome, thank you very much. I'm very curious in this. This is it doesn't look pretty, but it doesn't have a rubber tire on it either, and there's nothing here to absorb moisture and become conductive. So I don't know, you know, the Packard Bell test set, that flyback may never fail in our environment out here. But we're definitely going to get this back in the Zenith right now and see if it works. We're going to cover the flyback in a whole different video. I want to really focus on the vertical output in this video. This will make a great whole separate video, getting a chassis going, testing this, testing the cathode current, seeing how this holds up. So we'll come back to this in the future. Managed to get it installed, and it fits perfectly size-wise. It took a little bit of figuring out with the wires, because he used a little bit of different color wires based on what he had, which is okay. What I did is I left the original little wire nubs down in the, see them here, which designate the color green, red, green, black with a green stripe, red with a white stripe. So he used gray instead of blue. You can see the blue nub there. So I left all the original so I can always easily figure it out without the schematic. Unfortunately, I don't think I'm going to be able to fire this up today because we got a baked resistor right here, which I'd like to change while I'm in here, and I don't have the schematic for this exact chassis. These Elmincos should probably go. I don't know, I'm debating that. We're really just trying to see if this works, and the set was working good before the transformer shorted. So maybe I'll just change that resistor and we'll get it in and test it. And then we can go from there with maybe some caps and stuff. I took a look at the schematic, and this resistor that's smoked here is the resistor that feeds the B plus to the vertical output, to this red wire right here on this capacitor, the plate voltage for the vertical output tube. And that makes sense why this would be done, because when the transformer shorted, the primary wire, which would have been the red wire, basically shorted to the convergence, which is grounded. So I think this is more of a fuse type thing than anything. It's 470 ohms. So we got a replacement 470 here. We'll pop that in, then we'll try and get the chassis reinstalled, see how it works. The smoked one is currently testing in at 309 ohms. That's what happens when you cook these carbon resistors. They decrease in value. Now I got to figure out how to hook all this stuff back up. Zenith is not nearly as intuitive as like RCA. I did take pictures of this when I took it apart, but it's been so long it would probably take me longer to find the pictures than just to figure this out. So let me see what I can do, because some of the things stick on these pegs. Some of these pegs are test points. Well, I will concede I have no idea where these connect, and I looked back and found my pictures which showed pretty much everything I got except these, and I trace them up here and I don't know what they're for. So I got a message out to a collector who has all the factory service manuals for these, and hopefully he can shoot me a picture from the factory service manual, because it'll show the top of this and what all these pegs do. So I think we can power it up. We'll just see what doesn't work. Now we had some arcing over here. I think, I don't know, I might have damaged something. I don't know. We'll power it up and see. Okay, well here we go. And is anything happening here? Crap. I must not have the on-off connected. Maybe it's... Okay, there we go. I don't know what I did, but it's on now. And we have no vertical deflection. Before we panic, we want to check this, which is on setup. That would definitely do it. Something got bumped. Okay, try number 2 here. See, try number 2. Let's see what happens here. I got the brightness turned all the way down. Ooh, it looks like we have vertical deflection now. Look at that. But we might not have any activity from the tuner because maybe I don't have the power to the tuner hooked up. Oh boy. What a mechanical nightmare. Look at motorized. This is a remote set, so it's got all these motorized. All right, I think I got it figured out. Okay, now the next problem is because the focus was arcing, we have very low focus voltage. So I think it's probably the diode. Yeah, something got damaged here when it was arcing at the beginning of the video. I don't know if it's the diode or that resistor right there I have bypassed. It does get better when I bypass the resistor. I went back and looked at the intro part of this video where I came around the back and this wire was arcing to ground, the focus wire. And you can see this resistor glowing red in the middle if you go back and look at the beginning of the video. We got fire going in the flyback here. Imagine the amount of power it takes to make a 3-watt 47K resistor glow red. The voltage, it's a lot of power. Anyway, I'm going to do some testing here. I brought some diodes. I'm going to try and get this working. The main focus of this video is vertical output transformers. Big problem with Zenith. This area is a big problem too with Zenith. There's just a lot of power and heat in here. And I don't want to focus on this. I really want to focus on, did the transformer work? Does the convergence work? You know, is the linearity good? All of that stuff with the vertical. Trying to figure out what's going on here. So I subbed out the diode, and on this side, this resistor, 4.7 meg, goes from the center of this pot directly to the CRT. I got the CRT unplugged and I have drop across this resistor. I have 5.21 kilovolts there, and on this side of it I have 4.15. What the hell? Has the damn board become leaky? Has this become Oh, it is. Look at, see it? This red thing has become conductive. Now it's down to 2.8. This board, I just saw it arcing. So this red board has become conductive, this stuff, and it's draining the focus voltage off the ground. So yeah, I don't know if I caught it on video, but there was a little light there at the beginning of the video. So I'll show you the way we deal with this. Now, if you want, you could put some silicone there, but good camera work, dude. Good camera work. But yeah, I bet it's good now. I bet we get good focus now. This is a high hour set. Look at down in here. Look at the crust. Definitely a high hour set. And look at that. It's still a little soft, but it's much better. Well, to start, it looks like we got the vertical phasing flipped. And it's not quite that simple because there's two vertical output windings and a centering control between them. So is the primary flipped, and how's that going to affect the convergence? And why is the color demodulation so bad? This uses the IC, and these are usually always perfect. And I think I hooked up, that's color level. Yeah, it does look like there's a convergence issue. Look at that. And the tint is working. There's no green. So, and there's a bunch of ringing, and the focus is going in and out. I think that board has become conductive and it's just arcing everywhere. So minus all this ringing, the vertical linearity looks really good here. We just got a phasing issue, which this is a prototype, this is experimental. So what I need to do is I need to take the other one he made and compare it sort of in a autoformer and see if the windings are additive or subtracting, and I can figure out what he got reversed, because I can't just reverse the primary. That'll flip the picture, but if the convergence, if it's the secondary yoke windings that are out of phase, going the wrong direction, then the yoke will be out of phase with the convergence. So I need to figure out, comparing it to a new old stock transformer, see exactly what we got wound wrong here. But this looks good. It's just got to sort it out. Why kill your back when you can go in style? So this is another kind of Zenith pattern problem, that this red board becomes conductive. And probably the easiest way to deal with it is just to cut the board out, or cut cut around the conductive areas with a like a Dremel. I'm gonna clean this up, and then we'll take a look at the other transformer he made and try and figure out if it's the primary or secondary that's reversed from the original. There's a lot to consider here when trying to figure out what coil might be reversed, whether it was a mistake that was made putting the transformer together, or whether maybe I hooked something up wrong. I'm pretty sure I didn't, but you can always overlook a mistake when you're trying too hard not to make a mistake. So there's a couple different ways we could do this. So the problem, here's the problem, or here's sort of the layout. So you have the picture is flipped on the set. The bottom of the picture is at the top, the top's at the bottom. So it's flipped. So if the primary was flipped, it would flip the picture. If these were hooked up wrong, it would flip the picture. This is easy to flip. This you have to pretty much tear the transformer apart, because these connections are inside the transformer. Now, if this is flipped, it's going to flip the phasing on everything. If this is correct, this is flipped, it'll just flip the picture. We can correct this. We can correct this, because this is a single winding. We can't correct this because it's inside the transformer. We can't correct this because these are different taps. So there's a couple different ways to try and sort this out. Now, I'm assuming, since he made two of them, that this one has the same mistake, if it's a mistake. Got to be careful with that. That this has the same exact mistake as the one I already installed in the set. This is a new old stock Zenith. A couple different ways we could try and identify this and compare these two. We could put 110 volts here, and connect that to that. It should be additive or subtract, either buck or boost. Same thing here. Take red, 120 volts here, take red and also connect it to black. And then it should either add or subtract. And compare the two. We could also I'm pretty sure we could take and feed a triangle wave into here and then use a scope to look at the output, and if the triangle wave is flipped, it's out of phase. So if all of these are out of phase in relation to the stock transformer, we know that this is flipped. Easy, easy, easy. Just take the service saver off the bottom of the chassis and flip this one. Yeah, I mean, if this is flipped, we got to probably start over with a new transformer. So we need to just sort of compare. I think I might try and do the sine wave method and use the little crappy Sylvania scope here we fixed in a couple videos ago. So let me get my signal generator out, probably be a little bit safer than dealing with the line. Get a function generator and we'll start testing. What we have here is a square wave on the function generator with the duty cycle increased so that we can identify the polarity. So if I flip the leads going into the scope, the small will be on the bottom, and well, let me do it. So if I flip the leads, you can see we get the small on the bottom and the big on the top. So we can identify the phasing polarity of the transformer. So what I'm going to do is I'll just feed the function generator into the primary. I'll feed the function generator into here, and then we'll start comparing OEM to prototype. Get the function generator fed into both transformers at one time. He used a gray instead of blue. So I think what I'll do just to start is we'll start with orange, white, and orange, and he used yellow, white, and yellow on his transformer. So green is ground here. So with green on orange, white, and red on orange, we have the small at the top. On his, we have the same thing. Ooh, that's not good. Now I'm going from across this whole coil right here. I'm ignoring the two center ones. So I'm going from green, white to green, red. And with the same configuration, green on green, white, on green, red. And we have the same thing. We have the small on top. And on his, same thing. Same phase. Now this is a little interesting. So black, I have on the factory one, I have green connected to black, and I have red connected to black white, which is up there, and the phase is flipped on the original one. I think I know what happened. So with his in the same configuration, it's wrong. So what happened here is he probably followed this, but on the factory transformer, this is flipped right? Honest mistake. You would think that the bottom winding, or the bottom on the diagram here, would be the same, indicate the same phase on all coils, but it doesn't. This one is flipped, which makes perfect sense, which doesn't explain why the TV has the weird colors and weird picture, I don't think. One of these taps sends a blanking pulse up to the emitter of one of the video transistors. I could see where that might affect the video performance of the set or the color. But just having this flipped is going to flip the picture over. But we can't just come over here and flip this, because then this will... Well, we could come over here and flip this, and that would flip this, and then we could manually flip this, but we can't flip this because these are all different values. So I think it has to be rewound. Wow. What a bummer. Man. So again, just to clarify this, the correlation of this coil, this coil, this coil are fine. The correlation of this coil right here is backwards. These need to be reversed. But again, this connection is internal. And I really don't want to open these beautiful transformers up. Basically, there's a resistor that goes between here and here, which is the centering control. I wonder if I could just flip it and leave one of those out. I'll have to look at the schematic. Well, I pulled the 26S60 replacement out, and it's the same thing. The secondary that drives the yoke is flipped. Now, if you were going to draw this, and that phase was flipped in correlation to all this other stuff, wouldn't you join the two wires at the top? I mean, wouldn't that just be like intuitive? But it's this way. It shows it this exact way on the schematic too, on both the SAMs and the Zenith factory schematic. It shows the tie point at the bottom. When really what should happen is this one should come up and be tied with that one, and this one should be flipped, or something like that. I don't know. I don't understand why they did this. This doesn't make sense to me. But what I'm thinking about doing is just flipping I could show the schematic, but I'm thinking about just basically paralleling these two windings and bypassing the vertical centering control and just flipping these wires around. What could it hurt? So these are the coils that are reversed right here. So what I think I'm going to do is I'm going to tie these two together, and then I'm going to put a jumper over the centering control. This is one lead to the yoke coils off the center here. This is the other. So when you track this back and forth between the coil, it moves the centering. Probably because of the DC offset here. They're running the 390 volts B plus through this. So that creates like a DC offset between the two coils. So that moves the centering. So if you follow this over to here, it goes to 4 and 8. And four and 8, and then 6 and 7 go to the pin cushion. So we need to have the phase, because this is what the signal looks like. So we got this flipped over. So we need to flip it here, because the phase is important. Got the service saver cover off, and I'm checking this out, and I could either flip the wires around, tie the two secondary coils together and flip the whole thing, and bypass the vertical centering control, which is, I don't know, it's one of these pots down here. It's kind of hard to get to this way. Or I could flip the yoke, and I don't know if that would cause any problems. So I'm tempted. Also, talking to Marco, I could easily open this transformer and split those two coils, slice the tape, split those two coils, and add a fourth wire, and then tie them together in whatever configuration I wanted on the bottom. That's how we should have done it. Because we weren't 100% sure on everything, we should have just brought out another wire. But like he said, they're wound in this, I think he calls it bifiller thing, where the coils are basically laid right next to each other, the two wires. That way they're exactly even. So I think what I'm going to do is, I think I'm going to just flip the wires on the bottom here. I think I got this right. So what I've essentially done is tied black, white, and red, white together, and tied it to where black should have been, which is one side of the yoke. And then I tied black to where red, white should have been, and then I bridged red, white to black, white. So I've essentially paralleled the coils and flipped the polarity of it, which essentially bypasses the centering, the vertical centering control, which is this pot right there, vertical centering. So that should, as long as that pulse is not used somewhere else as blanking or something, it should work. It's just going to be centered like every other. I don't even, does RCA even have a centering control? I don't think so. I think this is only Zenith. You know, they want you to be able to get it absolutely perfect. Okay. The purity is jacked up because it's sitting up on its side, even though it should have degaussed itself. But let me put it on color bars. But the convergence looks okay. We'll have to try and adjust the convergence. The part that's screwed up is this, which is adjusted by the coils in here. Well, something's arcing on and off. Hey, I guess we're sort of getting there, huh? Let's give it some more brightness here. Got to get this whole thing kind of adjusted, you know. Let's see, where is brightness here? Look at that. So you can see the centering is off a little bit. It needs to be shifted down. Let me play with this. Let me see how good I can get it. I mean, that would probably... Oh, boy. Now you're cooking with gas. Holy crap, if that was still legal. See, I told you these things reproduce color very well when they're working right. Yellow's a bit washed out. That's a trip. Let me... that could be due to the purity from it sitting up on its side. As far as convergence goes, the static is off because look at the dots in the middle here, which is no surprise with it sitting up on its side and being moved around. I guess sort of the question is, well, you have to start with static first. We could play with that a little bit. You know, my main thing is, does the convergence work? Which is tied into that transformer. Listen to the transformer go. Oh, that's pretty. So there's a lot of arcing in this can, as you can hear. We need to come back and revisit this TV at a later date, I think. Get it dialed in and working great. It's got a new old stock CRT in it. I can't tell where the arcing is coming from. There's your blue glow. High voltage pulse regulator. I see where it's arcing. It's a frickin' tube socket. See that? The hell's going on there? Try and clean that out. There we go. Just like new. I did replace that resistor there with the correct 3 watt 47K resistor. Got all of that soldered back in. You can see someone replaced the horizontal centering control. Those pots like to burn up on these things. I need to replace the focus wire still. Put the right fuse in it. It just needs some TLC and cleanup and adjustment. And I think we are going to straighten the transformer thing out. I think he might make and send me a couple more. Plus, I'm probably going to take the other one apart and split that tie point up and bring 2 wires out so I can configure it the right way. I got the center convergence done. Now I want to just see if I can adjust this, which will tell me the transformer's working right. Putting the convergence panel here is probably like seriously the most intelligent thing, and it all works. You see, it all works. So I think we're good here. This transformer is good except those 2 things. In fact, the convergence looks pretty damn good. Yeah, this thing is good except the one winding being at the wrong phase, but who cares? You can't even tell. Vertical size works great. Look at this. To get it perfect, it really could use the vertical centering adjustment. You know, if I get the squares exactly even, it's shifted low. Look at that. See, that's the type of performance I would expect from a Zenith right there.
And all of that being on purpose, to have humans feel as people.
Welcome to the Buzz-O-Matic 2000.
Trey, that Hamas tried to float to the world, where there are 300, and then floating 50 were killed. They inflate that number so that if we were blessed enough to have the...
Our mission here at CNN is that the news comes first.
Oh, yes.
Call us to the Situation Room. We work as hard as we can to get the facts.
The Situation Room with Wolf Blitzer, tonight at 6 on CNN.
My active psoriatic arthritis can make me feel like I'm losing my rhythm. With Sky Rizzy to
Ooh, Sky Rizzy.
joints, I'm getting into my groove.
Ooh.
Along with significantly clearer skin, Sky Rizzy...
Nothing is everything, Sky Rizzy.
...swelling and fatigue. And is just 4 doses a year after 2 starter doses. Sky Rizzy attaches to and reduces a source of excess inflammation that can lead to skin and joint symptoms. With Sky Rizzy, 90% clearer skin and less joint pain all possible.
Serious allergic reactions and an increased risk of infections or a lower ability to fight them may occur. Tell your doctor if you have an infection or symptoms, had a vaccine, or plan to.
Thanks to Sky Rizzy, there's nothing like clearer skin and better movement. And that means everything. Now's the time to ask your doctor about Sky Rizzy. Learn how AbbVie can help you save.
Hi, it's Christina again. I'm here to tell you about an all-new special offer from my friend.
I was afraid I would fall. I called, and just one day, I had a shower I could feel safe in.
No matter your situation, Jacuzzi Bath Remodel has a solution for you. From a safer, easy entry shower with
I think we can call this a fix. It came out really well. Yeah, the centering is a little bit off. You can see at the top here, but you know what? This thing works really damn good, and it actually sounds really good too. So I'm impressed.
Another news conference today scheduled for 3 o'clock with state officials speaking. Earlier in the previous news conference,